Hi, welcome back. So we are in Chapter 1, Introduction at the Outline, Programming and Structure. In this outline, we're going to be discussing a general form of guidelines that govern the production standards when it comes to code something. So you see, regardless of the choice of the programming language you would like to use, I think there are some of the guidelines that you have to adhere to, because at the end of the day, whatever product you're trying to produce, somehow it will be available in the market. And maybe there are some other people who they would like to take over and build up where you have finished. So first of all, you have to choose an industry of specific coding standards. So I cannot tell you which specific code standard is the best, but I think if you have a good knowledge on the concept of coding in principle, that underlies the way you put your functions, modules, and the framework you're trying to use, I think that will help you actually to specify on the standard. Also, you must read about the available code standards using the language of your choice. For example, if you are using Python or C++, they should be in the documentation, so recommendation actually about the coding standard. Well, personally, I don't really have a specific language of my choice to say this is the one I always use. I like to let myself to be free and available to adopt any available programming language. Depends on the choice of the customer or maybe the environment. So that's why I do believe my understanding of coding and programming in general helps me then to go and choose the right standard or code. But I make sure always whatever code I have left behind, if somebody would like to come after that and try to recycle the code or build up one, that will be easier for them to follow. So the standard or the coding standard is quite a bit important. Next, maybe you can look or to focus on the code readability. This is very, very important. Choice of the name of the variables, the functions, maybe the also the way you put the codes all together are very, very important. I mean, sometimes I've seen some codes are really, really hard to crack in terms of understanding what was the coder thinking about, because maybe the calling of the function from some other outside functions or internal modules, the name were quite inconsistent. So even choice of putting the code or the lines all together quite a bit important. And be very careful in some programming language such as Python, for example. We have something called comprehensions. So in this case, we try to like capsulate the code. Instead of writing 3 or 4 lines, like for loops, we put it all on one line. This is a very strong thing, but you have to be careful because some people using the comprehension quite often more than they should, because at the end those comprehension can conceal kind of algebraic language somehow later. So unless you are doing, of course, some documented lines to explain what was going on. Next thing, you have to make a standardized headers for different modules. This is quite a bit important if you are dealing with a large project. Later we will be seeing in Python, for example, we're going to create some modules. Some of them are responsible for the backend, some of them responsible for the database. And within that module, there are some actually submodules inside there. And those submodules will be used by within or out the hierarchy, say, of the program. So you have to make sure that there is some headers explain about the model. Maybe I'm going to show you the general idea of that, although our project is going to be quite a bit small to do that. But really in large projects is very, very important, which part of documentation as well. Of course, we need to make sure we don't use a single identifier for multiple processes. So this is quite a bit important. When you have multiple processes running, you need to create a structure for identifying each process and so on. So you can just point one identifier to multiple processes. For example, we will be saying in the second project that we need to, for example, graph a real-time data, all right, but our application is running on its own. So I could have used the existing process, which is carrying our main application, and I used to graph the real time. So I have decided to do something else, create completely different identifier and different process to carry the real time process. So I have separated on two different threads, completely different. So my main application is still working on its own capacity and the real time, because I don't know if a customer would like to keep that open, or maybe small the window sided to somewhere on the screen. So you have to be quite a bit cautious about that. Next, you have to be looking at the turn daily backup into an instinct. It's very, very important backup, because sometimes you cannot anticipate local or environmental or any possible disaster things might happen. So you have to be conscious about your backup. You don't want your work to be lost. And of course, you need to leave comments and prioritize documentation. It's very, very important. Actually, I have done that personally in the simple project, but the idea can standardize them in a large or medium scale project. Finally, of course, you have to try to formalize exception handling. That means in any type of error, like in Python, for example, we have a block called try and except. So in case, anyway, try this. If it didn't happen, just to throw the exceptions in a different, maybe logging, handling mechanism, etc. So this is general guidelines of programming and structure, and just to keep you conscious around that. Next, we'll be looking at the last outline of this chapter, and that is development, execution, and maintenance. I will see you then.